Hello, good morning. I'm discussing today chapter alkane. First of all, alkanes are organic compounds that consist of single bonded carbon and hydrogen atoms. General formula CnStn plus 2. First of all, then energetics of reaction. The energy change during the chemical reaction is simply known as energetics of reaction. The bond between reactants molecules and dissociates. A new bond is formed during the chemical reaction. So the energy required to dissociate bond is called bond dissociating energy into isolated atom. The energy change during the chemical reaction is known as energetics of reaction. The bond between the reactant molecules dissociates and new bonds is formed during chemical reaction. So the energy required to dissociate bond energy is called dissociation energy into isolated atom. Every reactant will have a discrete amount of energy. Rearrangement of atoms that occurs in a chemical reaction is virtually always accompanied by the liberation or absorption of heat. Every reactant will have a discrete amount of energy. Rearrangement of atoms that occurs in a chemical reaction is virtually always accompanied by the liberation or absorption of heat. Bonds are broken in reactants and bonds are formed in products. In exothermic reaction, it is given off, that is, heat is produced by the reaction. As a result of this release of heat energy from the system, that is the reactants, the surrounding will have increase in temperature. Energy of reactant is the less than energy of the surroundings in case of exothermic reaction. So what? After heat energy is being released, products formed will have energy level, lower their reactants, energy of exothermic reaction, reactants, and products. Exothermic reaction, for example, carbon combusts under the presence of oxygen to produce carbon dioxide. Neutralization between acid and alkali. Zinc with tin chloride, metal displacement reaction. In case of endothermic reaction, heat energy is taken in, that is, it is required to occur the endothermic reaction. Systems reactants takes in energy from the surroundings. Surroundings loses heat to the reactants, that is, energy of reactant is greater than the energy of the surroundings. Products forms will have the higher energy than the reactants. Products is the higher than the reactants. For example, thermal decomposition of hydrogen sulfate, copper sulfate, anhydrous copper sulfate, calcium carbonate, calcium oxide, carbon dioxide, photosynthesis. Enthalpy. Enthalpy is known as heat content, is the total energy of system, sum of which is stored as chemical potential energy inside the chemical bonding. Absolute enthalpies for the particular states cannot be measured, but the change in enthalpy that occurs during a reaction can be measured using calorimetry. Enthalpy is the heat content total energy of the system, somewhat is stored as a chemical potential energy. Uh, Positive delta S for the endothermic reaction, heat energy is gained by system from the surrounding, and the surrounding will dip in temperature. Negative delta S, the exothermic reaction, heat energy is lost to the surrounding and cause the temperature in the surrounding to rise. For endothermic reaction, final products have the higher energy than the reactants. In case of exothermic reaction, final products have lower energy than the reactants. This is the energy profile diagram of endothermic reaction, and this is the exothermic reaction. Bone energy. Covalent bond exists in the covalent compounds. These compounds, covalent bonds, have the specific amount of energy to hold the atoms together. This energy is called bond energy. Energy is observed during the bond breaking and energy release during bond forming. Okay. Why do we need to study the chemical energetics? Chemical energetics leads us to understand a chemical change better. Example, what is the temperature for a reaction to occur? It will also tell us the energy barrier that reactants have to overcome before becoming the products. From the study of energetics, chemical energetics, we can understand chemical change better and also tell us energy barrier of reactants to overcome the products. Thanks for watching. Thank you for patient. Let's know. Bye bye. So again.